Hello, thank you. So to be honest, I don't know much about agriculture or horticulture, but this project started as almost a joke from a friend who is a garden designer and told me, you know, you're a computer scientist, so you should be able to figure out something about my problem. And his problem is that to be a good garden designer for that guy requires to be old because it's very difficult to learn and it's a very long process to learn about plants. So he explained me exactly what he does, and we try to figure out how it could be turned to a product. So this should become a very nice startup in a few months. But currently, I will try to explain you what's the idea under this project. How many persons here have a garden at home? Yeah, so pretty much more than half of the people. And how many know or think they know very much about plants? Yeah, a bit less. So our idea is we have quite a lot of people who wish they had a nice garden, but they don't really have the knowledge. And all the information that they can get is usually not adapted to their situation, meaning their garden, the location. So why not trying to design a garden assistant application that would give them advice adapted to their situation? So that's the main story. We have that person here who knows where he or she lives. And then given her location, we can know what are the local conditions, meaning what's the temperatures, the sunshine, the rainfall, and also given spatial data that we have now, where are the buildings, where's the vegetation there. So we can, from one simple information, which is an address or a GPS point, gather very much many information on there. Given the knowledge of the parcels in the cadastre database and the building and vegetation location in there, and with some additional information given by that person going in his or her garden with a GPS device, which is more or less a mobile phone, we can have a refined shape of the garden, knowing where every specific element is. Given the location, given the what style that person prefers, is it more natural garden or a French style garden or any style? Given the money she wants to put in it, and is there any water, any more additional water available? Do you want some insects, some bees to be, do you want a bee-friendly garden? And the local conditions, then we can suggest a set of plants that are adapted to their precise conditions. So there, this person can make a choice, choose a set of plants, and then she can preview what will be the colors in the garden depending on the season, because it will obviously change during the year. Then you have to plant or to define a planting pattern for all those plants in the garden. And then, given that planting pattern, you simulate the evolution of the garden during the years, let's say 2 or 3 years, to have a good idea of what that garden should be in that period of time. And then, ta-da, you have a very nice picture of a very nice garden. And if you like the result, of course, you order plants either online directly from a producer who will send you the plants, or you go to your garden center and you get the plants there. That's the general idea. Obviously, our target is very ambitious because there are many, many complex processes there, and we won't be able to develop all these very quickly. So we had to think of a first product, a first part of that process that would be really mandatory, and the first part that people would be happy to have. The first part we identified was some kind of plant finder. This plant finder is only the first part, so you tell us where you are, then we provide you information on the terrain, the slope, on the soil type. Is it acid? Is it alkali? Is that the English term? Where are the buildings? Where are the gardens? What's the climate? And then we provide you with a list of plants that would be adapted to your situation. Of course, so you might ask yourself at that point, but where is FME there? Did I choose the right conference to present this? I think so, because if you look at all the data that are required to provide such tools, then you need information on the digital terrain model, on the soil, on Earth observation to get information on land use, on the climate cadastre, and the plants by themselves, because most of the database that describe plants, they don't have all the information that we need for this kind of application. And of course, we need to gather information from various sources and put those information on our proper database, which is the backend of a mobile phone application. So I took just a few examples there because we don't have so much time. For the DTM, for example, so I don't have complicated workspaces where you can't see anything. And this is quite simple, but as input, we have a tile describing the DTM, so more or less a raster, often a geotiff raster or something equivalent. And then with very few transformers, we can compute a shading image of that corresponds to that digital terrain model. We can compute the slope, meaning if your garden is like this, it will be quite difficult to have a nice planting there. And what's the orientation? If it's facing north, you probably won't have the same plant species than if your garden is facing the south. So let's have a look at an example. This is a part of south of France. So the data comes there from the French National Agency, Geographical National Agency. It's a zoom in a small place there. So with this workspace, that's the input. And as output, we have the shading image that corresponds. And this will more or less correspond to the sun, the solar energy that the plants will be able to use. This is an image of the slope that we have calculated. In red, it's, I think, more than 30 degrees slope. And there we associate, so the colors are not very nice, I'm sorry, but in green, it's places that are well adapted to have planting because they are facing south. And in the not so nice color, maroon, or it's the places facing north, so probably you have different species of plants there. So that's the kind of processing we can do on the DTM part. On the land use part, we now have, so we had many talks about this, and I think Dimitri gave a talk dedicated to this one. When you have a very nice satellite imagery, so this is on the same area, detail over the region of Nice. You have that kind of, with a very simple workspace with FME, calculating based on the red band and near infrared band, you can compute very simply. NDVI stands for, I don't remember, anyway, it's a vegetation indicator. And as a result, you get very easily places where you have vegetation and places where you have something else. Regarding plants, as I said, there are many, many factors that we would like to know on plants. their name, and it's not so easy because the way plants are named can be slightly different depending on the the catalog of the plant provider. There are many species, but so you have the period where the plant has leaves, their color, the period where the plant has flowers, their color, dimension, the soil type that is adapted for those plants. Do they comply with a sunny place, or do they prefer shade? How much water they need, and the hardiness corresponds to the temperature, the minimal temperature, for which if the temperature goes beyond that point, then the plant doesn't survive. So let's have a look at this hardiness. How is it modeled? Usually it's modeled given what we call hardiness zones. So these are defined by the USDA, the US Department of Agriculture, I think. I didn't find any data on Vancouver, but that's the closest place I found. We have the same zone defined for France, and you see for each color you have zones. Red means that this zone, the temperature never goes less than around 4 degrees Celsius. Fahrenheit, I'm not very confident, it's 40. And mountains, obviously you have much lower temperatures. So we can use this information to select plants depending on the place where you live. And we also have found interesting information regarding observations. It's crowdsourced. People describe what plants they can see when they go hiking, or what plants they have in their garden, etc. And we have quite a lot of data regarding this. So with a very simple workspace also, they don't have a proper API, HTTP API, but it was quite easy to figure out what was the request that should be sent there. So with a simple HTTP caller, we can gather information from here. And so I think we download CSV files and then put it in our database so that we have those information for any individual observation of the plants there, which allows us to know for sure that in this area the plants are well adapted. Pretty much at the moment it's an ongoing project, so we still have a huge amount of work to do on that project, but definitely FME is a key building block to have all the data that we need to build the project integrated there. So unfortunately for you, James, so the garden designer couldn't come. He's much younger than me and good looking. If you are interested, so the image there, it's the garden he has designed for the Chelsea Flower Show in London, which is this week. So that's the reason why he couldn't come, and he won the gold medal Best in Show for this one. So put a link there. Probably it's unreadable, but you have the URL. If you want to consult the URL, it's quite interesting. Okay?
Thank you very much.
Sorry, I ran out of time. If there are any questions. Thank you.
Time for one quick question, if anybody has one. Okay, thank you very much, Frederick.
You're welcome.